Hi students, in this video lecture we are going to see the derivation for diamond section and triangular section. Okay, so first we will see diamond section. So this is the diamond figure or sectional view of the diamond. Okay, so the width is denoted by B and the depth is D. Depth height of the diamond is mentioned as small d. Okay, so we are splitting the diamond into two halves. Okay, so this is a neutral axis. Okay, neutral axis, and if we split the diamond into two halves means we are getting of equal areas. Okay, the portion 1 and portion 2 is of equal area. So this axis, the neutral axis, also called as equal area axis, EAA. Okay, so for portion 1 the center of gravity is G1. For portion 2 the center of gravity is G2. Okay, so the distance of the center of gravity from the neutral axis or equal area axis is y1 bar. Similarly, the distance of the center of gravity from neutral axis is y2 bar. Okay, so total depth or total height of the diamond section is D. So half of the diamond section is D by 2. So y bar y, okay, D by 2 is also the y is D by 2. Okay, so this is y1 bar. Okay, so center of gravity is here. Okay, so center of gravity distance, okay, from the apex is 2h by 3. So this is a triangle. Okay, from apex the center of gravity of triangle is 2h by 3. From base is h by 3. So y1 is from the base, so 2h by 3. So here the h is d by 2. Height of the portion 1 of the triangle is d by 2. So h by 3, h is d by 2. So d by 2 into 1 by 3. Okay, so d by 6. Similarly, y2 bar is equal to d by 2 into 1 by 3, d by 6 we are getting. Okay, so we know shape factor is equal to Zp by Ze, that is plastic section modulus divided by elastic section modulus. Plastic section modulus formula is a by 2 into y1 bar plus y2 bar. Okay, so a is equal to, first they are calculating area. Area is equal to, so triangle only. So half of the area of triangle is half b, so half into b into depth is d by 2. Okay, so into d by, so totally two portion of triangle, portion 1, portion 2, so into 2. So we are getting the final area as bd by 2. Okay, y1 bar is equal to d by 6. Already we calculated y1 bar and y2 bar and all, d by 6. Okay, and we are substituting in the formula. So therefore we are getting Zp is equal to, okay, so Zp is equal to a by 2, so a is nothing but bd by 2, so bd by 2 divided by 2 into y1 bar d by 6 plus y2 bar d by 6, that is equal to bd square by 12. Okay, wow. So after calculating Zp, after finding Zp, now we have to find Ze, elastic section modulus. So elastic section modulus is equal to I by y. First we are calculating I. So moment of I is moment of inertia. So moment of inertia is bh cube by 12. Okay, so moment of inertia for this portion of the triangle is bh cube by 12. Okay, so h cube is here is nothing but d by 2. Okay, so d by 2, so that is equal to b into d cube by 12 into 2 cube. 2 cube is nothing but 8. Okay, so bd cube by 12 8s are 96. Okay, so 96 into, so two triangles are here at the top portion and bottom, so portion 1, portion 2, so into 2 they are multiplying into 2. So bd cube by 96 into 2, we are getting as a 48. Okay, bd cube by 96 into 2. Okay, so cancelling this and we are getting 48. So bd cube by 48, and y is equal to total d by 2. Okay, total depth is d and y is equal to d by 2 from both the bottom and from top also. Y is equal to d by 2, so y is d by 2. So bd cube by 48 into the whole thing divided by d by 2. So we are getting as bd square by 24. Okay, So plastic section modulus BD square by 12 and elastic section modulus BD square by 24. So and we are substituting a shape factor formula S is equal to ZP by Z. So BD square by 12 divided by BD square by 12 into the whole thing 24 by BD square. Okay, we are cancelling and we are getting it as 2. So shape factor is 2 for the diamond section. Okay, so for this type of cross section of diamond, the shape factor is 2. Okay. Okay, students. Now if we will see the shape factor for triangular section. Okay. So the base of the triangle is denoted as B and depth of the triangle as capital D. The center of gravity is mentioned as capital G. Okay, so we know that the distance from the apex is 2h by 3. So here the h is d, so 2d by 3. Similarly, from the base, the center of gravity is h by 3, so d by 3. Okay, so the maximum y is 2h by 3. So first they are calculating elastic section modulus. So z is equal to I by y. We know that z is equal to I by y, and I is equal to BHQ by 36. Here they are calculating the moment of inertia from the base. Okay, so they are getting the moment of inertia as BHQ by 36 or BDQ by 36. Okay, so I by y max. So y max we have to put. Okay, so y max value is 2h by 3 or 2d by 3. Okay, so 2d by 3. Okay, so after simplification this we are getting z as bd square by 24. Okay, so after calculating elastic section modulus, now we are calculating plastic section modulus. So plastic section modulus formula is a by 2 into y1 bar plus y2 bar. Okay, so this is the figure. Okay, so b and d and all we know, and we are taking one more triangle through equal area axis. Okay, so framing the axis so that the triangle forming the area of the triangle at the top and the area, the portion below the neutral axis or axis, equal area axis should be equal. Okay, so portion 1 and portion 2 of area are equal. Okay, so for portion 1 central gravity is mentioned as G1 and portion 2 central gravity is mentioned as G2. Okay, so the distance of the central gravity from the neutral axis or equal area axis is y1 bar. Similarly, distance of central gravity from the neutral axis for portion 2 also y2 bar. Okay, and here the height of the triangle above the equal area axis is d1, and similarly the base of the triangle or portion 1 is mentioned or marked as b1. Okay, so now by using a equal area formula, okay, b1 divided by d1, b1 divided by b, sorry, b1 divided by b, b1 divided by b is equal to d1 divided by d. Okay, so this is a formula, b1 by b equal to d1 by d by using equal area formula. Okay, we all know a1 equal to a2 is equal to half of the total area. So a by 2. Okay, where a1 is equal to a by 2. So e1 is equal to half into b1 into d1, area of triangle of portion 1. So area of triangle is half b, it's half into that here the b is mentioned as b1 and d is mentioned as d1 for portion 1. So portion 1 a1 is equal to half into b1 into d1 is equal to a by 2. Okay, so a by 2, so 1 by 2 into a, area is half into bd for total area. So total area, total area of the figure, so half into b into d, b into d. Okay, so from this b1 is equal to d1, b into d1 divided by d, that only they mentioned here. b1 is equal to d1 into b divided by d. Okay, this value is come from here, comes from here. b1 by b is equal to d1 by d. From there b1 is equal to d1 into b divided by d. the comma. So 1 by 2 into, okay, they are in this formula they are substituting this b1 value. So 1 by 2 into b1, d1 into b divided by d into d1 is equal to 1 by 4 bd. Okay, this value 1 by 2 into 1 by 2, that is nothing but 1 by 4 into bd. Okay, so after simplification of this, we are getting d1 square b divided by 2d is equal to 1 by 4 bd. Okay, so d1 square is equal to d square by 2. Okay, further simplification of this, we getting d1 is equal to d by root 2. Okay, and we are substituting substituting d1 in the formula. Okay, here. Okay, and we are getting b1 is equal to b by root 2. So d1 is equal to d by root 2 after substituting d1 value in b1 equation, and we are getting b1 as b by root 2. Okay, so in the figure we are separating this figure only. Okay, we are separating this figure. So portion 1 and portion 2, portion 1 and portion 2. So portion 1 d1 only we have calculated. Okay, d1, okay, d1 is calculated as d by root 2. Okay, similarly b1 also calculated. b1 was nothing but b by root 2. So this value is b1. Similarly this one is also b1. Okay, so b1 b by root 2. Okay, the center of gravity y1 bar, and this is y2 bar. So y1 bar is nothing but y1 bar and y2 bar only we have to calculate. Okay, so y1 bar, now it is from the base. Okay, so for this portion 1, y1 bar is from the base. So this is a triangle. For triangle, the center of gravity from the base is h by 3, from the apex is 2h by 3. Okay, so from the base, so from the base is h by 3. Here the h is d by root 2. So 1 by 3 into d by root 2. Okay, similarly here, so it is a trapezoidal. Okay, so for trapezoidal, the center of gravity formula x is equal to b plus 2a. Okay, from both the sides. Okay, from top also or from bottom also, x is equal to, x is nothing but center of gravity distance. Okay, center of gravity is equal to, x is equal to b plus 2a divided by 3a plus b, the whole thing into h. Okay, so the bottom portion is a and top portion is b. Okay, so b plus 2a. Okay, so b value is b by root 2. So b by root 2 plus 2a. 2a is nothing but 2b. Okay, 2b divided by a plus b. Okay, so a plus b, so b plus b by root 2, b plus b by root 2 into h. H is the height. Okay, so total height. Okay, so total height is we already know the total distances d, total depth of triangle is d, and the portion 1 of the depth is d1. So the remaining depth of the second portion is capital D minus d1. Capital D minus d1. d1 is nothing but d by root 2. So d minus d by root 2 is the height of this trapezoidal. So here we are taking d as common. So d into 1 minus 1 by root 2, that is nothing but 0.293 d. Okay, so in the formula it is given as h. So h is nothing but 0.293 d. So 0.293 d divided by 3. Okay, this 3. So x is equal to b plus 2a divided by 3 into a plus b, the whole multiplication of h. Okay, so by using this formula only we calculated y2 bar. Okay, so y2 bar is equal to b by root 2 plus 2b divided by b by root 2 plus b into 0.293 d. Okay, so we know y1 bar and y2 bar. Okay, so y1 bar and y2 bar. So y2 bar, we are simplifying the y2 bar value. Okay, so b by root 2 plus 2b, here b and all comes common, so we are taking b as a common. So b, if we take b as a common, then 1 by root 2 plus 2. Okay, and we are 1 by root 2 plus 2. Okay, after cross multiplication, this 1 plus 2 root 2, the whole thing divided by root 2. Similarly, at the bottom, b by root 2 plus b, here we are taking a b as a common. Okay, after taking b as common, we will get a 1 by root 2 plus b. Okay, so after cross multiplication, we are getting b into 1 plus 2 root 2 divided by root 2, the whole thing divided by root 2, into 0.293 divided by 3. Okay, so after simplifying this, we are getting a y2 bar as 0.155d. Okay, so we know the ZP value, formula for ZP, a by 2 into y1 bar plus y2 bar. So we know the value of a, y1 bar, y2 bar and all, and we are substituting here. So a is total area, bd by 2 divided by 2. Okay, in the formula we are having one more 2. Okay, into y1 bar 0.236d and y2 bar 0.155d. Okay, and we are substituting and getting the ZP value as 0.09775 bd square. Okay, so therefore S is equal to ZP by Z. Okay, that is equal to ZP 0.09775 bd square divided by Z, elastic section modulus value. Already we calculated bd square by 24. So bd square by 24. So after solving this, we are getting S is equal to 2.346. Okay, so the shape factor for a trapezoidal section of triangular section, shape factor for triangular section is 2.346. Okay, if the triangles of this type of cross section means the shape factor value is 2.346. Similarly, if we consider triangle in this view means, okay, this type of cross section means we are getting a shape factor as 2. Okay, that's it. Thank you.